Okay, hi everyone. How are you all doing? I hope you're all safe and healthy. And there hasn't been a contest screencast on this channel from a very long time. I would say a month. And yeah, there would be a contest screencast today, wherein I will be attempting the educational code forces round 109. And yeah, let's see how this one goes. There are already like 20,000, I would say 19,800 people who've registered for it. And yeah, so yeah, I wanted to tell you that there has been a new video on the channel wherein I have talked about the mistakes that people make while doing competitive programming and how to avoid them. So you can check out this video. I will leave the link to it in the description. And I was expecting a good response from this video. I did not get it. But yeah, maybe that was because the channel has been like really dead for the past 1 month. And I will be posting more regularly now. So another 1 minute to go. And the primary reason I wasn't posting a lot on the channel was that I was sick and my whole family was sick. So now we've all recovered, and maybe we can, maybe I can be more regular on the channel now. So I hope I'm recording, yeah. And let me check my Sublime quickly if it's working fine. Okay, seems like. And other than that, today in the video, my face cam will be at the top corner, other rather than the bottom corner. So you can leave out comments about how you feel about this, and if I should switch back to the same thing or is this better. So yeah, let's get into the contest now. And problem A, you have initially an empty cauldron and want to brew a potion in it. The potion consists of two ingredients, magic essence and water. The potion you want to brew should contain exactly K% magic essence and 100 minus K% water. In one step, you can pour either 1 liter of magic essence or 1 liter of water into the cauldron. What is the minimum number of steps to brew a potion? You don't care about the total volume of the potion, only about the ratio between the magic essence and water in it. A small reminder, if you pour E liters of essence and W liters of water into the cauldron, then it contains, right, the percentage of essence in a good portion. So how many steps will it require? That is what they're asking, right? So if they want 3%, so I guess I can just divide 100 by the ratio, by the GCD of both of these. Because that will be like the minimum number of liters that we have to pour here. So this seems fine to me, and I'm submitting this one. Okay, c.cpp, right? And let me close this. Okay, great. So it has got accepted. Moving on to problem B now. So you're given a permutation A consisting of n numbers, right? You can perform the following operation: choose some subarray of A and rearrange the elements in it in any way you want, but this operation cannot be applied to the whole array. Okay. For example, if this is the array and you choose the subarray 2, 4, right? Okay, 2, 4 as in about, they're talking about the indices. They're not talking about the numbers here, right? This is fine. Your task is to calculate the minimum number of operations described above to sort the permutation in increasing order, in ascending order. Okay. So I can always do it in two steps. First of all, if I just select the first n minus 1 numbers and the last number, then this can be done in two steps. Yeah. So if either the first number is 1 or the last number is n, then this can be done even in one step. Okay, let's see. So I hope this works, because at max you need two steps. After two steps, it is always possible to just sort it. And can there be any other situation when there is only one step required? Hmm, no, I don't think so. So this seems fine to me. Okay, wrong answer on test 2. So let me think about it. Let me check the standings to see if other people are making wrong submissions on this as well. And okay, it seems like, but let's see. So first of all, it is always possible to do it in two steps. Yeah, it is always possible to do it in two steps, and 0 is also fine, but the case is about one step. If you have 1 at the very beginning, then you can select the uh, last suffix containing n minus 1 elements. If there is n on the last one, then you can, yeah, select the first whole thing. Okay. Oh, how am I getting? Okay, sorry. This should have been. Okay, 0 is fine. Then if I have 3 comma 2 comma 1, what about this? Okay, it tells me two steps. I don't think I can do it in one here. Right, maybe I have read the problem wrong. Given a permutation A consisting of n numbers, choose some subarray contiguous segment and rearrange the elements in it in any way. Cannot be applied to the whole array. That is fine. So can there be any other way that it requires only one operation. Or can it require more than two operations as well? Okay, I think it can require more than two operations as well. If one is at the very end, then you will first have to. Okay, let's talk about this. How will you do it in two steps here? If you select this, then you get 3 comma 1 comma 2, and then if you select okay, this is fine. So if arr 0 equals to n and arr at n minus 1 equals to 1, then you have 3 steps. Yeah, this should require 3 steps actually, because first you have to move one to the side, and yeah. Okay, great. So this was like a very cool edge case here. Everybody has a wrong submission on this problem. Okay, nice. Moving on to problem C now. So there is not a single submission on this problem as of now. Not a single correct submission, I would say. There are n robots driving along an OX axis. Okay. There are also two walls. The ith robot starts at integer coordinate xi and moves either left or right with speed of 1 unit per second. No robots start at the same coordinate. Whenever a robot reaches a wall, it turns around instantly and continues his ride in the opposite direction with the same speed. Whenever several robots meet at same integer coordinate, they collide and explode into dust. Once a robot has exploded, it doesn't collide with any other robot. Okay. Note that if several robots meet at a non-integer coordinate, nothing happens. For each robot, find out if it ever explodes and print the time of explosion if it happens and -1 otherwise. Okay. Right. Let's see. And what do we need to print here? What are they asking? So the ith robot, okay, the time that it explodes. Nice. Okay, let's talk about when will there be no collision. So let me, right, so if this is 0 and this is m, let's say, so how many blocks are here? 1, 2, 3, 4, 5, 6, 7. Okay, and if you are here and the other person is here and you want to move here and he wants to move here, so what will happen is after time 1 he will be here, you will be here, then here, 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 here. Okay, and then you both will collide at the same time here, then you come here, 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 and then the same thing will happen. So if like m is, like second, 1, 2, 3, 4, 5, 6, 7. So this will be like 1, 2, 3, 4, 5, 6, 7. Yeah, if m is odd and there are two people who, you know, have an odd distance between them, then they cannot collide basically. And okay, what if m was even? 1, 2, 3, and 4, 5, 6, and you're here and here. So after 1 second, you will have these positions. Then he will go here, you will go here. Okay, 1, 2, 3, 4, 5. This should be here, right? After 2 seconds, he reaches here, you reach here. And after 3 seconds, this person reaches here, but you are here. After 4 seconds, he reaches here, you are here. After 5 seconds, he is here and you are here. So then also you cannot collide. Right, let's try to continue this. Okay, it is really difficult to visualize it. Let's look at problem 4 till then, if it is maybe easier. Let me look at the people who've solved this one. Okay. Let's look at problem D only till then, because it is pretty difficult to visualize problem C. There are n armchairs numbered 1 to n from left to right. Some armchairs are occupied by people. And armchairs numbered 1 to n, left to right. Others are not. The number of occupied armchairs is not greater than n by 2. Okay. For some reason, you would like to tell people how to move their armchairs to some other ones. If the ith armchair is occupied by someone and the jth is not, you can tell the person sitting on the ith to move to the jth armchair. The time it takes for the person is mod of I minus j. Okay. You may perform this operation any number of times, but these operations must be done sequentially. You cannot tell a person to move until the person you asked to move in the last operation has finished moving to the destination armchair. Okay. You want to achieve the following situation. Every seat that was initially occupied must be free. What is the minimum time you need to do it? Okay, this is cool. This is pretty cool. So let me think about this. Okay, let me just read the problem statement once again. You want to have a situation where every seat that was initially occupied must be free. Okay. Okay. So one thing to observe here is that, let me show it in OneNote. So if you have like two people who have occupied these chairs, and you want to find the minimum number of steps so that these two chairs are free, but some other two chairs are occupied now. So what I'm claiming is that this person will never have to cross here. This will never be the situation. And why would it not be? Because if you have to cross, why not just make this person go here and this person go here, right? So I don't think you will ever have to cross each other out. So what I can do is, if I have all these occupied chairs, I can keep a sorted list, and all these non-occupied chairs, and I can keep a sorted list. So the thing here is that if I tell this person to go to this index, and then this person will only go to an index that is higher than this, and similarly this person will only go to an index that is higher than this. You cannot go here. This is what I feel. And yeah, so I don't think there should be any crossings here. It is not at all required to cross. So what I can do is I can make an order of n square type of a DP. Yeah, that should work. Yes. Let's remove this. Right. Then I have vector. Or I can keep it like this. So if a equals to 0, then I put it in the non-occupied one, else I put it in the occupied one. And n1 equals to sz of v1. And n2 equals to sz of v2. So if the occupied are already 0, then you don't need to do anything. If n2 right, otherwise what you do is, so how will this dp work? Okay, let's do it recursively. So I will pass the two indices, and here I have 0, 0, and n1, n2, and we don't need to pass dp here. Okay, I also need to pass in these vectors, so I can maybe make them global. If j equals to 0, that means I have used all of these all of these occupied ones. So return 0 in that case. If okay, int available, let's see how many chairs are available. Int available equals to n minus I, right, and int required equals to m minus j. So if available is less than required, then what do you do? Then you return infinity by 2 maybe. Yeah. Apart from that, if dp at I comma j is not equal to -1, then you return dp only. Okay, so now there are two things. Here I'm not using any unoccupied chairs, and in answer 2 equals to v1 at I minus v2 at j. Helper I plus 1, j plus 1. And I also need to sort these vectors. So let's see the answers. Okay, are there test cases? No, there are no test cases, right? Okay, so I don't even have to do all that v1.clear and all that stuff. 3, this is fine. Okay, 9, again fine. And this is that base case. We've covered this one as well. So it should be giving 0 as the answer. Yeah. Okay, I guess there is a TLE or maybe a runtime error. But I will have to see how to fix that thing. Okay, time limit exceeded. Ideally, it should not exceed the time limit. Everything seems to be fine here. So let's try out this case. Okay, so if j equals to m, then you return 0. Available is n minus a, required is m minus j. So if available is less than required, then you return infinity by 2. Oh my god, I did not update the DP. Okay, now it should be fine. Let me just see. Oh my god. Okay, great. So now I can look at problem C, although problem C still seems to be undoable for me. And I have made a lot of wrong submissions already. So there is a very huge penalty already. Right. So problem D was interesting. The idea that two people should not cross each other, that was, I guess, interesting here. And problem C now has 40 submissions. And only all these pro people have solved it. So yeah, I will have to think a lot to solve this one. Let's see this E problem. Okay. I don't know which problem should I go with. Should I go with E or should I go with C? Maybe I can read E problem for a minute or two and maybe see if I can solve it. In this game, he manages a great empire, builds cities, and conquers new lands. In cities, in order to conquer new lands, he plans to build one monument in each city. The game, in turn, based and since Monocarp is amateur, he builds exactly one monument per turn. One monument in each city, okay. Monocarp has M points on the map he'd like to control using the constructed monuments. For each point, he knows the distance between it and each city. Monocarp works in the following way. When monuments work in the following way. When built in some city, a monument controls all the point at distance at most 1 to the city. Next turn, monument controls all points at distance at most 2. Then the turn after at distance at most 3 and so on. Monocarp will build n monuments in n turns, and his empire will conquer all points that are controlled by at least one monument. Monocarp can't figure out any strategy, so during each turn he will choose a city, okay, randomly among all remaining cities. Monocarp wants to know how many points he will conquer at the end of turn number n. Help him to calculate the expected number of conquered points. Okay. So if I try out all possibilities, then we still have to check which points are to be included. So this M is pretty large, like I cannot test out all possibilities and keep checking for every point. That is the first thing. Okay, so if I try out all the possibilities at the end I will still have to do this, right? So I will have to figure out a way to calculate this value efficiently, the number of points that are getting included. Okay. Something like 2 to the power n into n should work here. That is what I am aiming for. And if I can maybe have a log factor with this, then that should work as well. But I will have to see how to calculate this thing efficiently. Okay. This is an interesting problem. It should require some heavy data structures to do the ending part efficiently. But I guess I can continue with problem C only. It seems more doable than this one at this point. Okay, let me think about problem C while I roam around. And let me read it once again to just sort of revise the problem statement. There are robots driving around. One is at coordinate M. The ith robot starts at an integer coordinate xi and moves either left or right with the speed of 1 unit per second. No two robots start at the same coordinate. Whenever a robot reaches a wall, it turns around instantly and continues his ride in the opposite direction with the same speed. Whenever several robots meet at the same integer coordinate, they collide and explode into dust. Once a robot has exploded, it doesn't collide with any other robots. Okay. The very first thing is that I cannot iterate on all these points and calculate how many robots will reach, at this point at so and so time. I cannot do that. Right. Once a robot has exploded, it doesn't collide with any other robot. Also, here the thing is that, after, how should I explain it? So, if you have all these robots here, then if after some time they all, go here, come back here, and then reach this point again, then all of the robots that are able to reach their same position again will never collide. Because that is just like, the whole process repeating itself. And if they would have collided, they would have, uh, they would have never reached that point again. And if they're reaching that point again, then the same process will repeat and it will be the same. Right. So that is one observation here. Also, maybe I can do a binary search here. I don't know. I just sort of have a very vague idea about binary search at this point. Okay, let me think about it. Okay, so another observation that I have at this point is that if there are if there are two numbers that are of same parity, I mean, if they're of different parity, then they can never collide. So I can maybe test it with the code itself if this is true. Because I tried out a bunch of cases and it was coming out to be true, but I can just try out some random cases here. And what is the range of n here? Okay, m is at least 2, right? So let's see. Rather, I can consider int L. Okay, we can also decide the direction they're moving in. If L equals to 0 or L equal M, then we can flip the direction it is moving. Similarly for R. Also, if dir1, then you have to increase it. So L plus plus, L minus minus, R plus plus, else R minus minus, and we have count plus plus. So if I consider my M to be, let's say 4, I can consider my L and R as 1 and as in 2 and 3. Then M is 4 and directions are 1 and 0. So let's see. So there is no output. Apart from that, if I keep it 5, then let's see. So there is no output as well. And let me try to make this 1 and 2. So again, there is no output even if they are moving in the same direction. Let's see if they are moving in the same direction and there is you know, a collision, and there is no collision again. So if I consider 1 and 3, and the first one is moving this side and the other one is moving here, let's see if there is a collision. Yeah, there is a collision. So there is only a collision if they're of same parity, and maybe I should test it with 4. I don't think there will be a collision again. So yeah, it does not depend upon M. All it depends upon is uh, the parity. So if they're of same parity, then only will they collide. Otherwise, they won't. Right. So that is a cool observation. Fine. Let me think more about this. So now I can separate all of this into 2 categories. Yeah. Let me see. Right. So I sort of have an idea for the C problem, and I will first have to segregate the odd numbers and the even numbers here. And I will also have to see if I just create a function and I pass in the 2 points, when will they intersect? If I know for sure that they will intersect. And let me look at the standings just a minute. Okay, cool. Or I can do it like this, char only. Right. Or I can create a pair only if I have to store all these. And let me look at the time that is remaining. 50 minutes. Okay, 50 minutes should be fine. Let me close this. We are looking at problem C for now. And I also need the indices, right? So maybe the idea of creating a point was okay. Right. But then it will be a little difficult to debug because I haven't created a function to debug a point, right? So sort. Okay, let's keep it as it is. Okay. Okay. Now what is the issue here? Oh, I haven't created okay, now it's fine. So I can sort of just debug it. I.x. Let's try it out for the very first test case. It will be easier to debug. Right, so you have 1 and R, 3 and L. Okay, now these are separated. So it is pretty clear that only the points that have the same parity, they will only intersect. That is fine. Now how do I just sort of get the answers? Okay, how will I store them in a set now? In fact, I don't need a set, I can just create vectors. So if b at I dot direction equals to R, so that means it is going towards the right, then we can just insert it and continue. R dot pp b at I. Else, if sz at lr is greater than 0, then point p equals to r at sz r minus 1. I do r dot ppp, that is pop back, and I update the distance here. In fact, I don't. Okay. Right, okay, that was fine actually. And here, I just calculate the distance between them. So how do I do this? P dot x x2 equals to v at I dot x. So answer is how much? Answer one is ABS x1 minus x2 by 2. Yeah, this should be fine. So how do I do this now? Answer at P dot index equals to answer 1. Answer at V at I dot index equals to answer 1. And this is fine. Point P equals to this. R S Z I dot index. Okay. So this is fine. Else what do we do? Else we check for the left one. If SZ, else we just insert it. I dot PD B at I. Okay. So how do I calculate the distance in this case? This is tricky. Right, so at first we need to calculate how much distance will they travel. Right, yeah. Uh, okay. So there can be at max one point in this L vector. That is what I see here. Because they would get, neutralized. Yeah, that is great. It can only have one point. So this is fine. So P will reach 0 after so much time, and V at I. In fact, I should consider it like point P and point Q. That would be much better here as well. Right. Q dot X minus equals to answer 1 because it is moving towards the left. And then the answer is answer 2 equals to answer Q dot X divided by 2. And since they're of the same parity, it should actually, yeah, this is fine. Answer at P dot index equals to answer 1 plus answer 2, and answer at Q dot index equals to answer 1 plus answer 2. Okay. Let's see. Debug is ambiguous. How is it ambiguous? Okay, let me try to do it here only. So you have 9, 4 and R, 11, 4, 11, 6 and R, and 10, 5 and R. Okay. So now we need to look for these R values, right? Yeah. And if any one of them is left, then we can just include that left and right. Okay. So while S said at R is greater than 2, and then after this we will try to merge the L and R. So point P equals to R at S at R minus 1. Answer 1 equals to M minus P dot X, and P dot X equals to M. Q dot X plus equals to M. Sorry, it should be answer 1. And then you have answer at P dot index equals to ABS at P dot X minus Q dot X by 2. In fact, I should make it answer 2. So answer at P dot index equals to answer 2, and answer at Q dot index also equals to answer 2, and then I do R dot PPB twice. So if SZ at R equals to 1 and SZ at L equals to 1, P equals to R at 0, Q equals to R at, what do we do? R at sorry, L at 0. LLX equals to minimum of P dot M minus P dot X, and because it is moving towards the right, and LLY equals to minimum of L at sorry Q dot X minus Q dot X. So what do you do? Okay, it should actually be, this is fine. To travel, how much do we have to travel? Minimum of X and Y. So we do P dot X plus equals to 2 travel, and Q dot X minus equals to 2 travel. So one of them would have reached the location. So if P dot X is not equal to M, then you do P dot X plus equals to, okay, travel 1 equals to M minus P dot X, P dot X right, P dot X plus equals to 2 travel, and Q dot X plus equals to 2 travel. Similarly, else if Q dot X is not equal to 0, then what do you do? 2 travel 1 equals to Q dot X, P dot X minus equals to Q 2 travel, and Q dot X minus equals to 2 travel 1, right? And then the answer is LL answer 1 equals to ABS at P dot X minus Q dot X by 2. Answer at P dot index equals to answer 1 plus 2 travel 1 plus 2 travel 2. Okay. Okay, I don't know what was the issue here. Maybe I should try to close it and run it again. Okay. Okay. So it is showing -1 for that case, right? This is 5 and 7. So let's try to do this. So we don't have 5 and 7 here. Which case are they talking about? Okay, 9, 10. They're talking about 9 and 11. So how did it not get merged here? Okay, let's try to see if I'm doing everything right. L and R. So if it is equal to R, then you cannot do anything here. Then you just simply put them inside the vector. Yeah, you try to do this. This is fine. Else L dot PPB. This is also fine. Else you insert inside that. So what I can do is, So I'm not getting any output here. This means, okay, I'm getting it here. So this should have been fine, right? Okay, it should have been greater than equal to 2. Still, I'm getting 1 here. I shouldn't be getting 1. Debug, answer 1. Answer 1 is 1. Okay, it should have been answer 1 plus answer 2. Okay, this seems to be fine. Let's remove this, or rather let's just remove this and see if I'm calculating the answer at every point correctly. Answer 1 plus answer 2, yeah. Okay, let's try to run it for the whole thing. So the answer seems to be fine and I'm submitting now. I think it should work. I've covered all the cases. Okay, great. This was a very implementation heavy problem. I mean, you will have to decide how to implement it even after you get the idea. So it was pretty difficult for me. Okay. I don't know if I should try out the E problem because there are only 25 minutes remaining. I don't think I will be able to do that because there is definitely a lot of complex data structures involved in it in order to do the last part efficiently. So yeah, I'll be ending the recording at this point.